Today's lecture is lecture number 1 in engineering geology. In chapter 1, we need to understand what is the importance of engineering geology for our study, for our future study of geotechnical engineering. So let's first discuss what is geotechnical engineering. For those of you who did not hear about geotechnical engineering before, this is what we usually see when we look at any site or any place. You will see a bridge. This is a bridge. You will see a building, a small building or big building. Here, this is a tower, small building, commercial building. This is a harbor. This is the harbor where ships go to this place to change the cargoes and something like this. So this is a harbor. This is what we usually see. But what we did not see is the full picture. What is the full picture? This bridge, it has below ground, there is something called foundations. What is this foundations? You heard, maybe you heard about piles, you heard about foundations, shallow foundations, deep foundations, but there's lots of types of foundations. Do all bridges have the same type of foundations? No, each bridge has its own type of foundation. How can we choose this type? Which is better for this type of bridge? It really does not depend only on the type of the bridge, it depends also on the type of the soil. So I need to know what is the soil beneath so that I can design adequate type of foundation. So this is one thing. This building, there is a basement below the building. So this basement is below ground. It is affected by the ground. And it rests on soil. Is it the same soil as that below the bridge? No, it may be completely different. Even within the same building, it may be 2 types or 3 types of soil within the same location. So I need to know what are these types of soils. There is a tunnel. I did not see it from the it is not, I cannot see it from above. It is below the ground. There is a shaft. Shaft is something they dig a cylindrical hole in the ground and go deep to do something, to maybe to construct a footing or a foundation or so on. So there is something different. So this tunnel and this shaft, is it affected by the soil? Yes, of course. If the soil formation is different, we know that in Suez, below the Suez Canal, we have many tunnels. Are all tunnels the same? No. Some tunnels are in Port Said. The soil there is very, very soft. And some tunnels are in Ismailia, the soil is very good. So this tunnel is completely different than this tunnel. The method, the design method, the construction method is completely different. So I need to know what is the type of soil to design my tunnel. This harbor, is it standing? You know why do we do harbors? What is the importance of the harbor? Have you ever thought of it? Why do we need a harbor? You have seen, maybe in Gaza or in many places, when they see a ship in the sea, the ship cannot come to the shore. Why? Why the ship cannot come to the shore? Because if it approaches the shore, it will be stuck because of the shallow depth. So if I want my ship to reach me, then I have to prepare something like this. What is this? It's a high land so that my ship, when it comes near, it is far away from the bottom, so it can reach me without touching the ground. This is what is a harbor. Before that, what they used to do, the ship used to stay in the middle of the sea. People would go in small boats, ride these small boats, go to the ship, and come on top of the ship. So instead of doing this, no, we build a harbor, something like this, so that my ship would come to me. I go from the land directly to the ship. How can I put this structure? Especially, it will be resting on the bottom of the sea. It is very soft. The bottom of the sea, of course, is softer than you have touched it yourself. When you go to the bottom of the sea, you find that the soil is softer than the normal soil. So I have to build a structure here. This structure is resting on something called maybe piles. This wall of the, of course, if I leave a vertical wall like this, it will tilt either to the front or to the back. How I would keep it vertical? I may put some kind of inclined piles or tendons or anchors just to keep my wall vertical. The design of this anchor and the design of these piles depend on the type of the soil. So all of this is the full picture. So from this I now understand that to design any good structure, I need to know the soil very good. How can I know this type of soil? I will go to something else called site investigation. I will need, before constructing any of these things on top, to go to the site, dig few deep holes, take samples, test these samples on the site, and take some of them to the lab, test them, and when I test them, I know what is the type of the soil, what are the constituents, what are the percentages of these constituents, and then I will need some equations. Why I will need equations? Because if I knew the constituents and the percentages, then I can get these equations to transfer the constituents and the percentages into numbers. If I tell you that the soil is sandy soil, clayey soil, does this mean ring a bell? Does this give you any indication about the exact properties of the soil? No. I know that it is in the category of sand or in the category of clay, but is it strong, medium, weak? I don't know. So I need to transfer the type of soil into numbers. If I tell you that I have sand and the parameter of this sand is, say, there are two very important parameters, something called C and something called phi. These are two important parameters for the soil. If I tell you I have sand with phi equal to 30 and C equal to 5, you will know exactly what is the strength of this. Because I am an engineer, I need you to give me numbers. So if I have 30 phi and 5 C, if I compare it to another soil with 35 phi and 10 C, obviously the 35 and 10 is better than the 30 and the 5. So I transferred the material from just description into solid numbers that I can use. This chart is very important because it gives me the relation between few things that we need to understand before we start our study. We all know what is science. all of what we are studying is mainly based on science. Science is divided into three major parts. It's applied science, natural science, social science. Of course, if we are speaking about soil, it means that we are speaking about natural science because soil is natural. So this natural is divided into biological and physical. We always need the physical properties of the soil. So we need the physical part of the natural science. So this is what we reach. Physical, natural science. Okay. This physical is divided into many parts. The part that we need is called earth science. It is the science that deals with earth. Of course, we don't need astronomy. We don't need to know the stars and what is happening above us. We only need to know what is earth science. So earth science is what we need for our study. Earth science is divided into many things. What is important for me, as I told you before the start of this lecture, is the geology and hydrology. Geology is what we are studying this term. But we are not going to take the full geology, we are going to only to take the engineering part of the geology. The other science is called hydrology. Hydrology is the science of water. Of course, if I give you a soil sample, a dry soil sample and a wet soil sample, do they have the same properties? No. Wet soil sample is softer. So it means that water has an effect. So I have to study water. But if I study hydrology, it will take me lots of time. But you may have studied hydraulics in other subjects. But for us, we are not going to take the engineering hydrology, but we will give you what we need from hydrology during the study of geotechnical engineering. But for geology, we have to dedicate a special course for engineering geology. So both of them end up in having geotechnical engineering, and this is what we are going to study next term. Okay, what is the difference between, we were speaking about science, but we ended up with engineering. What is the relation between science and engineering? Has anybody of you thought about it before? What we are studying are sciences, but what we are aiming to study now is called geotechnical engineering. It's not geotechnical science. So there is a difference between the term engineering and the term science. What is the difference? The difference is that science studies the world and creates questions. If you look at any scientist, you will find that this scientist discovered gravity, and this scientist discovered electricity. He discovers, but he does not build. He does not put solution. There may be some scientists who will tell you that there will be an earthquake in this area with the magnitude of so and so. Okay? This is the end of what he's doing. But he cannot tell you how to construct a building to withstand or to carry this earthquake without damages. This is the role of the engineer. So engineers or engineering presents solution. So scientists discovers the problem, discover the nature around us, give us questions, how can, or at least give us data. They will give us the data that we need in our design. For us engineers, we take the data from these scientists or from the science that they present, and we use it to present solution. I want to store water. The scientist will tell me what is the amount of water that will be available, how strong it will be, and so on. He give me everything, but he cannot tell me how to design a dam to store this water. So engineer presents solution. How can we do this? We do this by three things: analysis, design, and construction. We analyze the problem to understand what is this problem. We put a design based on what we have studied from their sciences, and then construct the building that we want to build. So now we understood what is geotechnical engineering, but let's now study why geotechnical engineering. Why do we study geotechnical engineering? Is there a benefit in studying geotechnical engineering? Maybe. If no one studies geotechnical engineering, what will be the effect on us as human beings living on this earth? If we don't study geotechnical engineering, this might happen. What is this? This is a road, and this is a high land, and this road is in the low land, and there is a ramp, slope between the high land and the low land. What happened? Failure happened. And due to this failure, if you look here, you will find cars here, and maybe there are few cars below this failure. So are there casualties? Yes, there may be casualties. Maybe people were dead because of this failure. Look at this similar. It's also a high land and a low land, and next to the low land there is a village, very close to the slope. And what happened? Maybe during night, during their sleep, there was a failure. And people who were sleeping in their homes found themselves below the rubble and below the soil that has fallen from this or collapsed from this slope. So were there a way to prevent this? Yes. Yes. At least as a minimum, as an engineer, we will tell people stay at least few meters away from the slope. If we cannot stop the failure, we will tell the people what is the risky zone so that they would avoid this place. But we can reshape the slope to prevent the failure. So we can do both. The easiest way is to tell them, go away from this. Don't go to this place. Like if you have a place like Japan. In Japan we have very, very strong earthquakes. If I don't have enough experience, I will tell people don't live in Japan. Live in China. It is easier. But if I have to live in Japan, then I have to study geotechnical engineering and study earthquake and tell them how to build buildings to carry earthquakes. So it is, this is how we deal in geotechnical engineering. Another thing, why geotechnical engineering? This is a city, and there is a big hole. This is called a sinkhole. Sinkhole means that in the ground, suddenly you find a hole in the ground, and everything in top falls down. Was there a building here? Probably yes. Were there people sleeping in their home? Yes. What happened when they suddenly found themselves below ground, maybe 40, 50 meters below ground? Were they dead? Probably yes. Was there a way to prevent this? Yes, there was a way. We can do something like sonar, that ultrasound that we do on our stomach to check the problem. We can check the soil and tell you that there will be a problem at this location. Do not live here, or at least do something. If I cannot prevent, as I said, we will avoid. So in engineering, either we can prevent or avoid the problem. No, it has no relation with earthquake. It happens, we will study it in our course, but it happens just like this, because this is rock, and inside the rock there are cavities. Usually, مغارة علي بابا, when you go inside. So what about the top layer of this cave? Is it thick enough or not? If it is thick enough, then it will carry everything. Maybe there will be a building on top. But if it is thin and I come to put my building on top of it, what will happen? One day it will fall down. Maybe earthquake would be a reason, but maybe it would be a reason, but it is not the only reason. There are many other reasons that may be the cause of that. These are few pictures. This one was in London Heathrow, and this one is in Germany. By the way, I was in London studying during these two accidents. And I used these two figures in a research that I was doing at that time, and my reference was the newspaper, because it was not yet published in books. They were building tunnels below ground with a new method called NATM, New Austrian Tunneling Method. This new method has some limitations. It was not yet avoided at that time. So in 1 week, there was a big hole in Heathrow Airport, and there is another big hole in Munich, in Germany. And of course, if you can see that there is a full bus inside the hole. So of course, there was maybe some casualties. So it happened. Can we avoid? Yes, of course, with careful study of how to use a new method in tunneling. This is a dam. This cross-section is a cross-section of a dam. By the way, these photos were taken by me. It was in Jordan. In Jordan, they make you know about in Arabic البوتاس, شركة البوتاس, potash. They have factories there. They bring the water, the saline water of the Dead Sea. They leave it to evaporate, and once it evaporates, they take the salt and purify it and use it and sell it. So they need to store the water. To store this water, they need to make small dams. They call it dike, a small dam. This was a dike. This is dike number 18. So they have lots of dikes. But this dike was a little bit higher and bigger. Suddenly it collapsed. So our job here was to study why this dike collapsed. Was it the effect of the soil, or was it the effect of construction, or what is the problem? And in this area, we need to do a site investigation, and to carry the machine of site investigation, the soil was very soft. We cannot walk, so we had to use a helicopter to carry our equipment to the area where failure has happened. So it was it was a geotechnical study to study the effect, why this failure happened. So of course, after this, we did not hear that there were other failures that happened. So they managed to stop similar failures by studying geotechnical engineering. Thanks God here there were no casualties because it happened during night. Nobody was there at this area. It was only financial problems because the dike was a length of few kilometers of the dike were breached away by the water that was stored inside. So it was a problem, a financial problem, but no casualties, thanks God, happened. Another example, this is something, a building collapsed in Shanghai, in China. Of course, this is a building. It was similar to these buildings around it. What happened? Suddenly, this building collapsed as one piece. Of course, it was still in the construction period. People were not there, but there may be people working there. There may be people inside this building that has collapsed. Maybe there were people below this building and it collapsed on top of them. Who knows? But at least we know that there is a big financial problem that has happened. Can we prevent this? Yes. Because why this building only collapsed and this was still, and if you look at the building, it collapsed as one piece. No cracks, one solid building. Why? Of course, the problem was in the soil. What happened? What really happened in this building? They constructed the building and they wanted to construct the building next to it. So they dig a big hole to put the foundation. So they excavated a hole, a big area next to the building. Where did they take the material that they have excavated? They took this material and put it at the back of the building. So what happened is that the building is standing in the middle, in front of it a big hole, below it high pile of soil. So there is a tendency of soil pushing in one direction from the high location to the low location, and still it did not collapse. But what happened? Heavy rainfall. That's why I told you hydrology is important in our work. Heavy rainfall. So when rainfall, water started to seep from the high land to the low land, pushing the building. The building was designed on simple foundation to carry vertical load, but it was not designed to carry horizontal load. So the foundation collapsed and the building stumbled as one piece. It's a big problem. But it happened to happen once. So now you all know what has happened. You will not do the same in any site. The building is safe as it is, but you are not going to excavate next to a building and to take your excavation pilot at the back of the building and wait for the rain to come to destroy everything. So this is something. Of course, you all know this building. This is very famous in Alexandria. The building that has tilt. Was there a way to prevent it? Yes. You know what happened to this building? They had to demolish this building from top to bottom. So it was completely removed. There is no way to take it back to its location. Failure means failure. You cannot just straighten a building back to its Pisa Tower. Did they bring it back to its? No, it's still the tilted bridge of Pisa. So this building, of course, it is not a touristic area. People are not going to come to see it. So we have to demolish it. This was the fate of Pisa Tower. Pisa Tower should have been demolished and rebuilt. But what happened is that when they left it like this, people came to see it. So they kept it for us just to see it. It was a source of income. But it's something related to this place only. don't depend that your building, if it tilts, people will come to see it. No, they will put you in jail. It's a mistake. The person who designed the Pisa Tower might have been jailed for his problem. They did not know that maybe after 100 years people will come to see this his problem and will be very happy to see it. They did not expect this. So don't depend on that in your design. How can we do this? We can do this by doing site investigation. Now we know why geotechnical engineering, how to prevent what we have seen. This is, we will say it now in site investigation. In site investigation, this is the soil. By the way, this is from the net. It's not my drawing. Maybe I made some modifications on it only to use it. I'm standing on top here. Do I know what is below? I don't know. If I drill a small hole, maybe I will reach the first layer on top. But there is a layer here at the bottom, we call it a problematic soil. It's a problem. This layer causes problems for buildings. So I have to know it. How can I know it? I have to drill and go to this depth, take samples by a special way, send the sample to the lab or do the testing on site to assess the type of not all problematic soils are the same. There are many problematic soils, and how problematic I don't know. I will know if I do a good site investigation. So to study geotechnical engineering, I have to start with site investigation. I have to find out how we do site investigation to assess the soil below. How can I do this? I can do, as I said, just a small hole, but the problem of this small hole, of course, I will see good samples and so on, but it will be shallow depth. So I can bring something called boreholes. Have you ever heard about boreholes? Gasset? Yeah. Boreholes are very thin tubes drilled inside the soil, and I excavate within this tube and bring the sample on top. Of course, here I see the sample with my eyes, I take it as it is. But here, if I want to take a sample from this bottom, I will have this sample will be distorted because it will not come as if I give you some sand and I tell you keep this sand, take it to the other building. You will reach the other building with this sand distorted. It will not be the same. Maybe I put it in my hand. When you take it in your hand, it will be in a different shape. So the problem of boreholes is that you cannot depend on having these boreholes taking samples intact to the place where you want to study. You have to take into consideration that the sample has been distorted a little bit. It is disturbed. We usually call it disturbed sample. It was disturbed. It is not in the same shape as it was in the ground. How many boreholes I would take? Would I take, if I have a building an L shape like this, I will take my boreholes below the building. If I take one borehole outside the building, will it help me? No, it will not help me. But maybe I would use it for other things. Maybe here outside I would have something different. Maybe I would have a road. Of course, if I have a road and the road is swinging like this, moving up and down, it's not good. So I need also to know the soil, but it is not as important as below the building. So I may put here shallow boreholes or maybe test pit. How deep is my borehole? If I have a small footing and a big footing will affect a very big zone below it. A small footing will affect a small zone. If I expect that my footings will be small, then I need shallow boreholes. If I expect that my footing will be big, then I need deep boreholes. If my foundations are piles, خوازيق, as in Arabic, as we call it in Arabic, I know that it will go very deep in the ground. I cannot take 6 meter boreholes for piles that are 20 meters below the ground. I need to, if I'm having a pile 20 meter, then I would need to go at least 25 or 30 meter below ground. So the depth depends on my expected type of foundation. How can we do this? This is a borehole drilling machine. But also this borehole, it was taken in Dab'a nuclear power station. I took this photo. This machine can go down to 100 meter below ground. So it is very powerful machine, and it can assess the soil during drilling. It has automatic or computerized sensing, so that it can, during drilling, give me data about the strength of the soil. This is a test pit. I can drill a few meters below the ground and go down and check the soil. But especially in this photo, of course, this photo was also taken by me in Yemen, in Sana'a airport. But Yemeni people have very good talent. They can drill holes in their ground that can reach 10 and 15 meters. If you don't believe me, you see this thing at the bottom here? This is the helmet of a person standing. He was inside this hole. This is an engineer who was studying a sample. He is a geologist, not an engineer. He was a geologist, and he was studying a sample below ground. So this is at least 8 meters, and they can go deeper than that. But this is special about Yemen only. They do buildings very different type of. They can have a clay building that would reach four stories. It's very easy for them to do this. We cannot do it here in Egypt. We can just go one floor or 2 floors maximum, but they can build houses using this clay, and they can drill holes that can reach very deep inside the ground. But usually, if I do a test pit, it will be something like 2 meters, 3 meters maximum. Don't depend on more than that. But with a machine like this, I can go 50, 60, 100, similar to this one. So this is the test pit, this is a borehole. There is another equipment here. This equipment is called the seismic logging. The seismic logging is similar to the ultrasound that we do when we are sick and we go to the doctor, and he will tell us, do an ultrasound on your sonar, on your stomach to check whatever you have. We can do the same for soil. Either an equipment that would go on top of the soil, or I can put it inside a borehole to check whatever inside. This is a lab. In a lab, you will have all of these equipment and more. By the way, we have our lab here. It is very good, with very advanced equipment. So during our course, we need to go and check it to know what we are going to use in the future in testing. There are many. I'm not going to go deeper into this. It's not our task now. Just to know that there are many equipment in the lab. I just take the sample from the site investigation here. If I take a sample from here, I would give them to these people here, and they would do some tests, and they would give me the results. And my task as an engineer to assess the results and to know how to use it in my design. Then finally, I will do something called a geotechnical report. Of course, you have heard before the تقرير تربة, geotechnical report. What is Now you have done an investigation. You have the knowledge in your mind. How can you present it to other people so that they would know what you have done? Then you have to prepare a report. This report will include what? As a minimum, introduction and project description, of course. If I need to tell the people who are going to read this, what is this document containing? Then I will tell them my site investigation problem. What did I do? Boreholes, test pits, ultrasound, seismic testing, logging, what is the results, everything I have to put it here. Then I have to put the results and the discussion. Now I have done few tests. Then these tests, I have to put the results and comment on these results. Were they good, bad, they need my interference or not, something like this. Then finally, I will give people reading this report conclusion and recommendation. Is this site feasible? Do I have to use it or I have to look for another one? If it is feasible, what are the soil parameters that I will need? What is the strength of the soil? So I put everything. Usually, normal engineers cannot study all of this. They will go directly to the conclusion and recommendation, and they will tell you, they will read it and do whatever you put in this conclusion and recommendation. Then finally, you will have something called appendix. This appendix includes all the data that you have used in your report. If you have a data sheet of a test, put it. If you have photos, put it. If you have a borehole log, put it. Whatever you have, put it in this appendix so that it would be a complete document. Finally, to end up our lecture, just a reminder of the Pisa Tower. Usually I put it at the end of the introduction, that you have always to remember that mistakes are not always that lucky. Mistakes end up in jail, not in photos and be very famous and well known. No, don't expect this. So you have to study. Thank you and see you in the next lecture, inshallah.